Hello everyone, welcome to Studitable. My name is Swati, and in this video, we'll be talking about Git. What Git is, the history of Git, the characteristics of Git, and also we look into the commands that Git offers us. That is how we can initialize our repository, how can we add files into it, and the commitment of it, and also the transition from Git to GitHub. Okay, so there are different sets of commands that Git offers us, and we look into that. And this will be a full-fledged Git tutorial. So, there's a quick request that if you have not yet subscribed to the channel, please subscribe and hit the bell icon so that you do not miss any further update. And also, I continue getting the motivation to create videos. Okay, without much further ado, start the video. So, first we'll start what is Git. So, before starting the practicals, we'll first dive into some theory parts so that we can understand what Git is. And after that, we'll jump to the practicals. Okay. So, what is Git? Git is an open source distributed version control system. So, what is meant by open source? Let's say you're working in a company and there are a few projects in that company, and you are working in a project which has, let's say, a few team members. So only your team members have the access to the project. No other person coming from outside has access to that project, or they can make any contribution to the project. That is a company specific project. Only that company can work on that project, right? And only the limited set of people that are allowed to access that project can contribute to that and can work on that. Okay, but open source means it's available on the internet freely, and anyone can come and contribute to the project. They can view the source code, they can edit that, they can also add new features into it, they can clone it, save it on their own system. So open source is like an open ground, available for all who wants to contribute. So Git is such an open source project. Okay, and it's a distributed version control system. So what is version control? uh, if you are working, let's say you're working in a project and you are added a new feature into it, so the new features will be needs to be tracked. Let's say that you have let's say you have a file and you have added a few lines into it. You have saved the project there. Now if you're adding a few more lines into it, then who has done the contribution, who has written that line, and where, at when, and at what time the things were added. These things need to be maintained, and these things need to be tracked, so that in future if you want to refer ki, okay, what was the changes that I made, you can easily refer that. So for that we use a system called as version control, and Git is a version control system. Okay, so version control means any changes that needs to be done, they are done and they are saved somewhere in a special kind of database, and then they are tracked accordingly whenever they are needed. So if you want to go to a previous version, if you want to go to a previous changed update, then you can go and see ki, okay, who has done it and at what time it was done. So it is a version control. And what is meant by distributed? Distributed means ki that it is there on a central server as well as it's there on your machine. That is key. If your repository is saved on the server, then if you clone the repository, or even if you have the file saved in your system, then you will have the entire history of the project into your system, which means even if you cannot access the server for any reason, then too your work will not be hampered, and you will have the access to all the files, to all the committed history, to everything that is available, and you can easily continue with your work without thinking ki, okay, I cannot access the server. That is a distributed version control system. Okay, and there's a video on this version control that is from the channel Studitable, and the link will be there in the description below. So if you want to check that video, you can go and check that out. Okay, so in that video we have discussed the types of version control system, which is local, centralized, and distributed, and Git is a distributed version control system. Okay, so why is Git used? Git is used to design, handle minor to major projects with high speed. That is, the speed of Git is very high. That is, it can handle very small to very large projects, and it handles them with high speed and efficiency. That is, any changes that you made, anything that you do, that they are very efficient and nothing is lost. No change. Sorry, no changes are lost, and it is developed to track changes in the source code, enabling developers to work in collaboration. So any of the developers who are accessing the same project at the same time, same repository, so they can work in collaboration, because any changes is tracked and everyone can view that at what time and who has done the change. So this helps the developers to work in collaboration, and also it helps them to see the changes in real time, and also the changes are in high speed and efficient, and they are very efficient. Okay, So if we understand it with the help of an example, so let's say you have a kid who, and you click a picture of your kid with yearly, that is every birthday you click one picture of him for a memory, and also to gift him when he grows old, okay, and he becomes an adult. So you are clicking your kid pictures every year, from first year, second year, third year, fourth year, until the age of 15 you are clicking pictures. So that's a 15 photos that you have collected, that's a memory also. So every picture is different, every picture is unique, so you cannot go back to the previous picture and go, okay, I'll go and change that picture. You cannot do that, right? It's a kind of a snapshot. Picture is a memory, and also every picture is unique, right? So it's more like a you are creating a memory of your uh, kid growing from a certain age to a certain age, right? So in Git also, whatever commit you make, that is given a unique ID. That is, let's say that you have created a file and you have added 10 lines into it, and you have committed the file. So that file will be there in the Git repository. It can be into your local repository, or you can also push that into your remote repository over to the server. So whenever you do a commit, then each of the commit is given a specific hash value. That is, each commitment is given a hash value, which is the SHA-1 hash value, and each of the SHA-1 hash value are unique. That is, every commit you make, it's given a specific hash value, and that hash value is unique. You can check your hash values to go to Git log, and you can see all the commits that you have made, and each of the commit is given us unique hash value. So the hash value is cannot be changed. So if you make any more change, then a new commit will be raised and a new hash value will be generated for that specific commit. Okay, so this way Git keeps track of each and every commit that you make. That is, each commit is given a specific hash value, that is the SHA-1 hash value, which is the secure hash algorithm, and that hash value is unique for every commit. So this way Git keeps track of every commit that you make. So that is why, and what is there in the hash value? The hash value contains the data that you have changed, the author, that who has changed the value, that who has entered the value, and also at what time the commit was made. So it all of these are included in the Git hash value. uh, so each of the commits are unique. Okay, so if you go to Git log, you can check the different commits and different hash values of the data, right? So it's more like a snapshot of that whatever commit you make, you create a snapshot of that snapshot of that commit, and that snapshot is saved as the hash value, and that hash value is referred to by the project. And whenever, if you want to go back to the some commit, then it will whatever commit you want to go back to, it will compare the hash value, and if it matches, then it will be given to you. Okay, so this is how Git snapshot works. Okay, now we'll talk about some history of Git. That is, Git was developed in 2005. Before that, Bitkeeper was being used. Okay, so Bitkeeper and the Linux system were for the source code. They were working together, and initially Bitkeeper was used as a source control, where the different whenever changes were saved as patches, and all the patches, if collected, they can give you the complete file or whatever change has been made. But after a certain point of time, Bitkeeper started to charge to use the services. And since Linux is an open source project and also it's free for everyone, so Linus Torvalds do not want to take money or to make the service as a cost one. Matlab, he wanted to make that free and open source for everyone. So he started developing Git, and released in April 2005. And after since then, Git is being used as a version control system for Linux, as the main version control. And the developer of Git is Linus Torvalds, who is also developer of Linux. Was Git there because whatever after the Bitkeeper license was revoked, that is to reduce the time for updation and help to scale the system, and also support distributed version control. That is, you do not need to always access the server. You can also work if you cannot access the server, because you have the complete copy of the repository into your system. Git was written, which would take a very little time to apply patches, that is the changes, and update that to the project. So finally, Git was released in April 2005. Okay, and since then, Git is one of the major version control systems being used. Okay, and what are the characteristics of Git that we can use? It is a distributed version control system, that is the developer has a full copy of the repository and the entire history, which means that it can also work offline if they cannot access the server, and can also collaborate with other members. Effectual branching and merging, that is, you can create, merge, and delete different branches. What are branches? We'll look ahead into the video. And it is very easy to create a branch, and it support workflows like branching and pull request, that is pulling from the server. Speed and performance, local operations are very fast. Why? Because they do not require network access. You do not have to continuously connect to the server to work. You cannot work, you can work in your local system, and whenever you need to commit change, you can push the change to the repository when you are completely ready to do that. And you only require network access when you want to push your work to your local to your repository on the server. Okay, commands like commit, difference, and log execute quickly because they do not require internet access all the time. Staging area, that is, if you are adding a file into your repository, then you get a area of, first you get a modification area, that is, you have done some modification, that you have created a file. Okay, and you can add whatever things you want to add in that file, and then you pass the command git add and the file name. So it gets into a staging area, that is, the changes have not been committed yet, but it's there in that area. It's more like a green room, that where the contestants are coming and they are waiting there, and whoever the next contestant is, then they'll go and the rest contestant will continue to wait. Just more like a staging area, that is, the commits have not been made yet. So if in any point of time if you think, okay, I'm not ready to commit this and I want to add few more things into it, then you can uh, add more things into it, and then you can commit the file. Okay, so it's more like a staging area where it allows us to prepare and review changes before committing the file. Okay, so this provide complete control over what changes are included in a commit, that you can view there ki, okay, if you are ready to do that, then go ahead and commit. If you are not, then revert and add whatever you want to add. Okay, and also it has a strong community and ecosystem, that is, Git is widely supported with numerous tools, integrations, and platforms like GitHub, GitLab, Bitbucket. So there are a lot of people working on it, and so it all the time, since it's an open source project, so also it has different functionalities, and also there are a lot of people who can help out with different things, and so its functionality and usability is greatly enhanced. Okay, and this is a workflow of Git, that is, you make a folder in your local system. You pass, when you have created a folder there, you pass the command git in it, and the folder will be initialized as a git repository. After that, you can work in your local directory, or you can also work in places like notepad, or you can also use a command, the editors like vim or any other. And after that, when you are done, you can pass the command git add, and that will go into a staging area where you can review if you are ready to commit to a repository or not. If you are not, then you can you'll go back to this working directory, make changes, and come back to staging area, and when you are ready, you can do the git commit. Okay, and it will be added to your local repository in your hard disk only. This will not be there on the server. So when your complete entire project is ready, then when you are ready to push that to your server, then you can pass the command git push, and it will be there on the GitHub repository, that is on the internet, and where everyone can see that it's there, and it's open to all if it's a public profile. And any other developer, if you wants to view whatever changes you have done, if this a team member, and if you want to check the changes, if you want to check the contents, whatever is there, then they can pass the git pull, and all of the files will be there on their system, and they can also work on that. Okay, so this is the git workflow, how git works. Okay, so now we will be doing this practically. and let's jump into it and see how Git works in real. First, we'll be installing Git into our system. To install, we'll first go to the Git website here, Git installation. Okay, and in the download section, you'll find the option of to download Git, and based on the operating system, you can choose whatever version you want to download. If you are on Windows, then there is a for 32-bit Windows setup and 64-bit Windows setup, and choose whichever version is there. And for Linux and Unix and for Mac OS too, there are different ways how you can install Git onto your system. If you are using a Debian based system, then the command will be apt get install Git, and for Fedora is yum install. And for the same, if for Mac OS, you can either go from homebrew and use the command brew install Git, or if you're using Mac ports, then you can use the command here, right? And in any scenario, if you have Xcode installed into your system in Mac, then by default, I think Xcode with Xcode Git is there installed. So once you have downloaded, then we can check the version of Git here. So the option is Git version, and we'll find the Git version 2.4.3 into my machine. Okay, and you maybe your version can be a bit different, but if you are getting this, then it means Git is successfully installed into your system. Okay, once we are done, then we'll be doing some work into this Git. That is, we'll be adding files, we'll be making a Git repository, and then pushing our code into it. So there, if once we started doing that, then since Git is not something that only one person uses it, there are multiple people working on a single project. So if you do not mention that, okay, who is doing the updation or who is sending data, then it becomes difficult to track ki, okay, who is actually adding a few things into it. So the best is to do some configurations here. Okay, so before starting it, we need to do some configurations. That is, we need to first know that who is passing the commands there, and who is updating, and who is adding files into it, and what are the commits made, and who has made that commit. So for that, we'll be doing a configuration here. For that, we'll be writing git config. And if you wish to do that onto your local system only, that is the current project that you are working, then we'll go with local user dot name. Okay, which means ki in local, what will happen that only the current project that you are working on, or only the current machine that you are working, then that will be the configuration for that will be whatever you specify here, that it will not work for other projects that you are working. Okay, then this will be specific only for the current project that you are working, which is local. Okay, but if you want to just go for the single project, then go with local. But if you think that, okay, I'll whatever projects that you are doing into your system, in the operating system that you are using, then all the projects that will be going out from the system that you are using, and you do not wish to specify the username or the email every time, then we'll be using global here, because this is all, मतलब the username or the email id you specify here, then that will be by default accepted on all the git profiles, or all on all the git based projects in future, which will be made in the operating system that you are using, okay, in the machine that you are using. So you don't have to specify every time, so you will be using global. Okay, but I'll be using local here, because this is just for the single project, and I already have my git configured into the system. So I'll not adding it and in as global, but for the single project only, I'll be using local here, and the username will be, let's say, Anne. Okay, okay, I have made a mistake. I have not initialized it as a git repository. And also I have, so first we'll create a project here. So sorry, first we'll create a folder here, initialize it as a git repository, and then we'll do this configuration. Okay, So first we'll create a directory here, make directory. Let's name as git repository. Okay, now cd git, go into the directory git repository. If you check, then there's nothing into this project. Okay, and okay, there is no such file or directory existing in this folder. Okay, now we'll pass here as git init. Okay, once we do this, you'll see the message here that using master as the name for the initial branch, you can also change the name of the branch you want. Now I think the main is being used instead of master, but if you wish to change the branch name, then we'll be using this command here, init default branch name and the name of the branch you wish to choose. But by default, if you do not choose any name, then master or the main will be used here. And names chosen a master main trunk or development. Okay, git branch and the name here. So initialize empty git repository. Now if we go and check ls, then you will find that now a .git file has been created, and this is the file git uses to track every changes that is made into the directory. That is, whatever you add into this, if by passing the git add command or whatever things are done in this particular folder, then git is able to track this, and all the information is there in the .git directory. Now this is a .git folder which will be tracking all the changes, right? Now here we'll now add the config that we created there. Okay, now for the same, we'll be using user.email, right? And for email, we'll be adding an at the rate of email.com. You can anything that you wish to add, right? Once we are done, we can also go and check how we can check that git config list local. Okay, so because I'm not using global here, because we are just wish to see the list of the configurations made in the specific project here right now. So this is the username that I added, and this is the email that we added at the rate of email.com that we just added. If you wish to see all the configuration list, so you can skip this part and you will find all the list there, complete list of the git configurations. Okay, now once we are done, we'll be creating a folder here. Okay, okay, we're creating a file here, readme.md. readme.md. It's an empty file that creates empty files, so there's nothing into this file. If you go and check, if you wish to check the content, then you'll find there is nothing there because that creates empty files, right? So now if I wish to see the status, sorry, status, then you will see on branch master, no commits yet, untracked files, because this is the file that I have created, readme. But git is still not able to track it because I have not added it into the git uh, I've not added the file using the git add command here. And once I add this, then git will be able to track it, and I can make the commit after that. But this is the area of the modification area where something has been done, but still it is not able to track. So it is asking me to use the git add command to include it in what will be committed, bring that to the staging area. So once it will be there in the staging area, then we are ready to commit that. And uh, this time this is there in the modification area. Okay, so once I'm done, I want to add a few lines into it. So let's first edit the file here, and let me add a few lines here. This is a readme file, can, and it is made by Anne with email, and at the rate of email.com. Right, once we are done, save and quit. If you check the content here, then you'll find the contents here, right? Now if I pass the command git add the file name readme.md, then something has been done. To confirm, go to git status, and now you'll find some changes. Here we were finding them in the red color, but here we will find that color has changed to green, which means now git is able to track it. Okay, and things, this has not been committed, but now it's there in the git area, and now git knows ki, okay, there is one file which is there, and this needs to be committed, and once it's committed, then it will be there in the git repository, right? So uh, we'll make the commit, but there is one more message here. If you, any point of time, if you think that okay, you're not ready to commit this file and you're forgetting to add something, then you can take it back to the modification area by passing this command. That is, you're not, that is, you'll remove it from the staging area, and this will be unstaged. Okay, so we'll pass this command here to see what happens. Okay, cached, and the file name is readme.md. Okay, and we go and check, then it's again in the same modification area. Now you can add whatever lines you wish to add here. So if I again add a third line there, is the second line, and I have removed the previous line. Okay, and once I'm done, save and quit. Okay, now we'll again add it to readme, and if I again check the status here, then again this will be the this will be the staging area. Now this changes are ready to be committed. All right, so okay, let's commit this now. Git commit. We'll not write the file name here with the custom message here. We adding readme.md, because we must know that what we are doing, because if in the log, because if we are adding multiple files and if we do not add any message, then it will be very confusing what has been added and at what point things were done. So adding a custom message will be very helpful for you to know what was exactly done without actually going into each and every file. And once we are done, we'll pass, we'll enter, and now you'll find the message that one file has been changed, and there have been two insertions, and there are two lines in that file. And if again go to git status, we'll find on branch master, nothing to commit, working tree clean. Working tree means the repository now is the working tree, which the repository which we are working on is now clean, and there's nothing to be committed. All right, so this was the history of adding and the commit. And now again, if I wish to create one more file, now I'm creating one more file here, and this will be a second file here, and will be, then we'll be seeing the commit history, what we have done. Okay, so when I'll create one more file here, index.html, and edit this, and let's add a few lines here very quickly. Okay, so this is a very simple HTML example, that this will just print, this is the index file. Okay, now once done, save and quit. Right, now if I wish, I again, if I go again, go to git status, then you'll see that there is one untracked file here under the HTML, and is there in the modification area, and git is not able to track it now because it's not there in the git repository. It's not there in the git area where it can track files, right? So we'll use git add to track. This is telling me to use git add so that it can track the file. Okay, so we'll use git add index.html. Once we are done, then git status, now the file has been added to the git history, and now Git can easily track it. Okay, so before we commit it, we'll first go to git log to check the commit history. So here you will find that there is only one commit made, that is the commit that we created there. Here it okay, where is it? Git commit has this one, git commit that we did this. So this is the only commit that we did, and this is the hash value of that commit. So whatever commit we do in git, git creates a hash value of it and stores it as a snapshot. That is, whenever I want to refer it, then the hash value will be compared. So every commit is given a unique hash value. If I go and change that readme.md file again, then a new hash will be created. That it will not be the same. The hash value will change. So every git commit is given a unique hash value, and this is the hash value, and this is the author. It will tell me every commit is given a unique hash value, and the author, and at the time at which the commit was made, and the message adding readme.md. Okay, so this file has not yet been committed, so there is no commit history of that. So once I was git commit and the message adding index.html file. Okay, once I am done, if I go again, go to git log, then now you will find another commit here. This one, this is a unique commit id given to the this commit that we have just created, and it will be given the time and the author who has done it. Okay, adding, sorry, this one, this is the one, this is the one, yeah, yeah, adding index.html file, right? So every commit is given a very specific unique id, which git refers to whenever whenever it wants to cross refer the changes. And also this is used to track. Also git uses the id, uses the reference to track the changes. Okay, so this is how every commit works here, and this is how git tracks files. Okay, this is how git keeps track record of every commit by giving it a specific hash value, unique hash value, along with the author and the date and the time at which the commit was made. Okay, so now we'll move ahead. Okay, so now what I have done, I have modified the file here, the readme.md file, and I have added a third line into it, that this is a third line. Okay, there were two lines initially, and now I have added the third line. So let's quit this, and with the git difference command, what you can see is the differences that the previous file was, and now the new difference. That is, initially there were only two lines into the file, and now since I've added the third line, so you can find the difference using the git diff command and the file name here. If I just use the git diff without the file name, then too I'll get the same result, git diff. Okay, it's there in the modified area. Now if I add as git add readme.md, then again if I go to git difference, then you'll not find anything here, because now it's there in the staging area. So if your file has been added to the staging area, that is it initially it was there in the modification area and like it was not able to track it, but now it's there. Once you pass the command git add readme.m the file name, then it's there in the staging area. So just passing the git diff command will not give you the difference, because now it's not there in the modified area. To find the difference in the staging area, you have to pass the command git diff staged. So you'll see the difference between the two files. Okay, so this is the third line that was added. Okay, if I go to git status, then you'll find that this file has been modified and the changes to be committed. So I'll again commit the file here. There is a shortcut also, that if you do not wish to pass the command add, first add git add and then pass git commit, then you can also use the shortcut a/m. A is for add, m is the message with it, that is uh, added the modified readme file. Okay. Sorry, I have missed a word here. Git commit. Yeah. So now you have they passed a message that added the modified readme file, and one file has changed, and one there is one insertion there, right? So to check the status, now you'll see it's on branch master and nothing to commit. The working tree screen, working tree is basically the directory on which you are working, the project directory. Okay. And to find git log, then you'll see now there was the initial commit that was made, added the modified readme file. This is the latest modification. This was the index, and this is the added readme file. So this was the initial commit that we made. We added the readme file, then we added the index html file. Now the modified readme file has a new commit and is given a new hash value. Okay, and this is the sha1 hash value, which is secure hash algorithm, and now git will be able to track it. So this is a new commit, and this is the latest commit that we have created, right? So every commit is given a unique value. Now once we are done, now at this point of time I wish to push my project, or wish to push these files to a remote repository. So how am I supposed to do that? So we'll see the steps here. All right, so to include our code, or to push our files into a remote repository, you need to have an account on, either you can make your account on GitHub, or we can go ahead with GitLab, and this is GitLab, or you can also choose as Bitbucket. Okay, but for this series I'm using GitHub. All right, so first, what is GitHub? Thus, GitHub is a cloud-based platform where we can store, share, and work together with others to write code. That is, it is a server. It's a remote place, and which is cloud-based, which means ki you can access it from anywhere, where you can store, share, and work together with others. You can collaborate with others. Okay, so you need to have an account on GitHub. So for that, we'll go to github.com, and here click the sign up, where you will be given a message, welcome to GitHub. Enter the email id, whichever email id you have, and then on continue you have to enter the password of your choice, and then you'll be logged in. So I have my GitHub account. So this is my GitHub account here, and these are a few repositories that my account holds. So to first, we'll create a folder here, and then we'll create the corresponding directory in our local machine, and then we'll see how we can sync both of them, so that whatever you want to push from your local system, you can do that uh in the local, sorry, whatever you want to push from your local system, and it will go to the remote repository. And how you can do that, we'll see here. So first, let us create a new repository here. So let's name it as uh, git remote. Okay, no, not git remote, git tutorial. Yeah, git tutorial. And this is available because this will not check it in the entire history of the repositories of the world, but this is just checking if I do have the repository of this name. But since I do not have a repository of this name, then this is available. And write any description, this git tutorial demo. Okay, and this is public because I want the people to see this repository. And if you keep it private, that only you and the people you allow can see them. I'll not add a readme file here, because I'll be adding them when I create them locally, and I'll be pushing them in the remote repository. So I'll adding the readme file in my local system, and then pushing that, and I don't have to do any more thing. So let's create the repository here, right? So once I create the repository, you will find a few things here. Set up GitHub Copilot, I'm not doing that, and there is no such collaborators to this repository at this point of time. So once we are done, then there are a few steps that we need to do on a command line, and Git is already providing us. We'll we'll do create a readme file and echo, that is copy this line into that file, and then we initialize it as a Git repository, add the file, commit it, and then so we'll be following these steps. Okay, so let's go to our terminal. Okay, I'll minimize this so that I can see what's going. Okay, sorry, so that I can see what's going there. First, reduce the font. Okay, and and clear the screen. All right. So first, we'll do the first step that is given to us. Echo hash git tutorial. Also spelling, and we'll move it to readme.md. Okay, there's a mistake here because, okay, no, what I'm gonna do is I'm going to create a new directory, a name with the name of the same name that is there. And what was the name that I chose? Git tutorial. So I'll create the same name as Git tutorial here, right? And cd git tutorial. Okay, once it's done, now follow these steps. You can also copy if you do not wish to write. Copy this. Okay, and paste this here. Okay, if I do an ls, then I'll find a readme file here to see the content. Git tutorial, fine. Now we initialize this as the Git repository. So what happened, that is again the same message that we are on default branch master, but we'll change the name here because master doesn't look very good, and Git is also promoting to stop using master and start using main or some other branch name. Master doesn't look good now. So we have done that. Now we'll do the next steps there. Git add. Before that, first check the git status. So you'll see that these are untracked files that are ready to be committed, readme.md, and we'll add that in a moment. Okay, and if we check the git log, then does not have any commits yet. ls, then there's one file. Okay, now we'll add the command here. Git add readme.md. Okay, now again if I go to git status, then you'll see the changes are to be ready to be committed. Now what I'm going to do, I'm going to do a git commit m, and whatever is written there, first commit. Okay, we are following the steps right here. One file change, one commit is done. Again go to ls, and sorry, not ls, git status. You'll find on branch master nothing to commit, working treatment. At this point of time, we'll change the branch. How to do that? Git, write git branch, the name of the branch. Okay, and the name which you want to go to, the branch that you wish to use. So I'll use main here. Okay, now again if I go to git status, now you'll see on branch main, and initially it was on branch master. Now the branch has changed from master to main, and git is also promoting to start using main and stop using master. Okay, now the next step is to add a remote repository that we have. So if I try and copy this, this is not showing an error, but if I go and check I don't want to lose this page, so I'll open one more GitHub page here. Okay, if you see this, then I'll show it again. Okay, now these are the repositories that I've created. This is the folder that we just created. So the readme file has here, it has if I show the content you of the readme file, then it has a line git tutorial. But if I go here and check, so you will see that there is no such line here, and there's still showing a setup. That is mean whatever is being done, it's not reflected here. Why? Because there is no connection between the local and the remote repository. That is, both are same, but how will github know that who is doing that and from where the project is coming from? So we need to merge them, or we need to sync them, so that any request or any uh, code changes you do, and if you wish to push that to your remote repository, then the server should know ki, okay, this is coming from this place. So they need to verify that it's you. So what can you do? That we'll go to uh, the repository that we had, and this is the repository here, and there are a few things that you can do. But before that, I'll show you one more thing. That let's There are few things that you can do in github now. So now in git, if you are going to a repository, then there are a few things that you can do here in the repositories here. That is, if you see a folder, or if you see a file, and what you can do is, if there are a and if you wish to download the entire directory into your system, then there are few ways. That if you click here on code and download, you can use the option of download zip. Okay, so that will download the entire history of the project into your system. That is, whatever commits have been made, every history of the project will be downloaded into your system, right? Another way is that we can do https. We'll copy this path here, and then using the clone command here, that is git clone. And if you write here git clone and the name of the repository, the name of the entire project that you wish to clone, that is here. If you copy this and paste the entire path here and press enter, then this will clone the entire repository into your system. Okay, now if you see that this was the full command, and this is cloned into my system here. All right, so I'll find this full project into my system, right? There's one method. Either you can do a download zip, or you can pass the git clone command here, right? But this is for downloading. But if you wish to upload, then you need to use these lines here. That is the git remote add origin, and this path is for ssh, this path is for https. Yeah, so but the problem with https is that it needs to verify, since it's over the internet and you are constantly using a browser. So it needs to verify that who is it coming from. So every time you need to log into your system, that is, you need to give your id and a password, and after that you can in some places the password is not accepted. You have to generate a key that we need to pass here, and you a pass key kind of a thing, and you need to enter that. And the password is not accepted at many places, in many systems also, that you cannot include a password there. The password is not being accepted. So you need to create a pass key, and then enter that in the place of your password, and then after that you can add your repository to the github. So instead of using https, we can use ssh here, and for that we need to create a key pair, and you will only create it once for the system that you are working on. So whatever system you are in, whatever operating system you are using, so once you create that key and paste it in your github keys, we'll see how you can do that. So after that, github will always verify okay, this is coming from this machine and this user, and it will always accept your request. Okay, so you need to do only this once, and this works for only single machine. That your machine specific keys will be generated, and only your machine will be accepted. If you're using some other machine, then you have to create key for that separately, right? So we'll be creating a key here, and for that what we'll do, we'll be using the command ssh key gen /o. All right, and this will be creating a private public private key pair, more like if you have used AWS, then you must have seen that they also generate a key pair where public is there on the server and private is with you, and the keys are matched. So enter the file. So I think there is no such specific requirement that I need, so I'll press enter. This is already existing, so I'm overwriting. Yes, I will need to overwrite this, and there is no such passphrase. Okay, I'll enter get get. Okay, same passphrase again, get. All right, so this is saved in this location, right? So how can I find that location here? So first we'll go to, this is an image, so we cannot make anything out of it. We need to save the key in my GitHub repository. So we'll go and find that key and paste that. Sorry. So first go ls/la, and here, okay, first enlarge this. I'm not able to see anything. Okay, so find .ssh here. Okay, in this particular directory is our ssh key saved. So we will go to cd.ssh, right? Here you'll find the id.rsa pub. All right, to verify what was actually created. So this is the id ed25519. This is the id ed25519.pub. This is the one we need to find. Okay, so this is one id ed25519.pub. So we need to find this, right? So let's do a cat and copy this entire file. So we'll paste this entire file here, and now this is the complete key that we have generated here. Okay, so we'll first copy this entire file. Okay, copy, and this is my machine specific key, copied. Now we'll go to GitHub here, and here we'll find, go to settings here and find ssh and gpg keys. Fine. Now there are a few other keys. New ssh key, title, git tutorial. Okay, and paste. Right, now add ssh key. So in some places you will be sometimes you may be asked to enter your password to verify. So now I have done, and this is the latest key that is added today. Okay, now I'll verify if this is working or not, right? So let us go back to the folder that we were in. First clear the screen. Now git tutorial. Okay, and check the files that, yeah, these are okay. I don't know. Okay, this was actually cloned into this, so I'll remove this. So now if I check that there's only just one file, so I'll verify if that, add this now, right? Remote origin already exists. Okay, so now to verify, I'll pass the last command, git u origin push, right? So once I do this, let's see if this works or not. So now it's giving me a message that it has been done, counting objects, writing objects. Now to verify ki everything is exactly how it's, if how I think it is, I'll refresh this page, and now you will see that there is a readme file and the message of git tutorial. All right, so this actually worked. So what we did exactly, we first we created a repository in my GitHub account, a new repository with the name of git tutorial, and then we created a key pair using the command ssh keygen /o, and then we copied the key, pasted that into our ssh keygen, pasted that into the area known as ssh and gpg keys, and once the key was verified, then we passed the command, which was git remote add, and this is ssh. We are doing an ssh here, we're not doing http. Okay, do not confuse this. This is the we are remotely accessing our server through ssh, right? So this is an ssh command, and then after that we did our origin main and our repository. Whatever code we have written, we have pushed that now there finally, right? So this was how you can create a new repository on the command line and push your code into that. All right. If you have an existing repository, let's say I have created a new repository, but if you have an existing repository, then too you can use this command and go to the branch that you wish to have. If you have a different branch, then you can choose that and you can do the push there as well. Okay, so now what I'm doing here, that I am adding a few lines into readme.md, and I wish to see that if my changes are pushed in real time or not. Okay, so these are a few lines that I'll add. Okay, is a these are a few lines that I have added, and I wish to see that if this now the changes are added to confirm the if everything is fine. Okay, now this has been done. Now if I go to git uh, status, then you'll see that okay, and there is one more problem, that ds store is also being added. So we'll see how we can actually remove ds store, and that will not be committed. If you by mistake, if .ts store, if you're using a mac, then you will encounter the problem of .ts store also being added, that these are the system files in mac and they automatically are picked up by git if you do not add them in git ignore. Then if you have .ds store into your git repository, so how you can remove that, we'll see. But first let me add the readme.md. So I'll add git add readme.md. Now if I again go to git status, then okay, I think I have need to readme md. Yeah, so now it's case sensitive, so I actually entered it all in small. So now if I git commit, do a git commit readme, actually you have to write a message here. So now modified readme file. Okay, if I do this, then it's there. But if I go and check, so if I go and check in my repository here, then you'll find that there's nothing here. So what we're gonna do here, we'll again go here and use this command. Okay, so once I do this git push u origin main, then you will see that the things have been added. Now to confirm, what I'm gonna do, again go here and refresh this, and now you'll see that now all things have been added. So now git is doesn't ask me for any kind of verification or anything. Whatever I have added, once I do the commit, it will be there in my local system, and the moment I'm ready to push it into my remote repository, I'll pass the command. We'll pass the command here, which is git push you origin main. Main is the branch name. You, if you have a different branch name, then you'll write the branch name here and push it to the origin, that is to the main branch here. And once we are done, then whatever is there in my remote repository, that will be pushed to the whatever there in my local repository, that will be pushed in the remote repository, right? So this is how you can actually enter, or you can say you can actually push your repositories from your local system to the server there, and it's public, so everyone can see that, everyone can view them. If you have collaborators, and you can have multiple people working on the same project. Okay, so now this was all for adding, and now we'll look into how you can create a branch and how you can switch between branches. And once, if you have added a few files to your branch, then how you can merge them with the main branch. Okay, so now we'll talking about branch and how you can create branches in git and what branches are exactly. So what are branches? Let's say you are creating a new project, and it's not feasible to do everything in the main branch, because if you screw things, then all the repository, the control, entire your github repository will can be compromised, and also you will be showing too much commit history in the uh, main branch. So that's not good. But if multiple people are working on the same repository, then every time if you do all your work in the main branch, then whatever commit history you do, whatever things you do, it will all be reflected and everyone can see that. So it doesn't look good. So it's better that we create a different branch, some other branch, that is some other area, more like a blank slate for you, where you can do your things, and what when we are ready with your entire work, then you can push that work to the main branch. You can merge those two branches together, and then the main branch will also know ki, okay, a different branch was there and the work that branch was going on. Now you can update that branch, and main branch will also refer to the same things, right? So how you can create a branch here? Check here, we can pass the command git branch, and there is only one branch here. To if you go to my repository here, and if I refresh, then you can see that there's only one branch is being shown here, which is the main branch. Okay, you can also create a branch from this area, that is, if you click here and I write the branch name, then a branch will be created. But I do not wish to do this from here. So what I'll do is that I will go to the terminal and I'll create a branch from here. So the command is git branch, the name of the branch, let's say web, right? And git checkout or web. So now I'm switched to my branch web. On which branch I'm in the web branch. So there is also, you can also use switch instead of checkout. You can also use switch. Now switch is also being used, and there's a shortcut also, that if you do not wish to use the same two lines, ki first create the branch and then check out to that branch, then you can also use the line git checkout slash b for branch and the name of the branch, let's say web 1 here. So switch, you will, the branch will be created and will automatically be switched to that branch, right? So to confirm, we are on the web 1 branch. And simultaneously you can also use the command switch instead of checkout. If you do not wish to use checkout, then you can also use switch. But in switch we use the c command, that is the create and the name of the branch. Okay, now we'll be switched to the branch. So you can either use checkout, you can either use switch, whatever you wish to do. Okay, now you have I have three branches, so I need to work on the web branch. So first we'll go to my web branch there. So how can I do that? Git checkout web, okay, or git switch web, right? Now I'm switched to the branch web. Now I'm on the web branch. The star one is the branch that is currently being used, so I'll delete the two branches that I've created extra. So how can I do that? Git branch slash d for delete, and the name of the branch web 1. Now that branch is deleted, and for web 2 that is also deleted, right? Now to check, now only two branches are there, main and web, right? Now I'll create something in the web branch. Okay, I let's say I need to create a index.html file here. Okay, now I'll insert a few lines into it quickly. Now once done, save and quit, right? To check the content, to if it's there. Okay, now it's there, right? Now if I switch the if I check the git status here, that the files that is been created in this branch, you will see that it's telling me that the changes are yet to be committed. Okay, but first I once I commit it, it will not be there in the main branch. So first we'll switch to the main branch to see if it can view these files here. So I'll use the command git switch main, right? Now if I check, then it index.html is there. Why? Because I have not yet committed the file, so it's not there in the working directory, but since it's there in the local system, so the repository can, the local repository can view this, but the branch will not know once I have committed this file in the different branch. Okay, so I'll switch to web branch again, and now what I'll do git add index.html. Okay, and again if I check the git status, you'll see that changes are to be committed, right? So I'll commit the change, git commit with a message adding index.html. Okay, now things have been inserted here. I'll check the content. There are two files, index.html and readme. Now I'll switch the branch again, main. Okay, now I'm switched to the branch main. Which branch I am? Git branch, and I'm on the main branch here, right? Now if I check the content, you will see that only readme is there, because git is not able to track, sorry, the main branch doesn't know that index.html file is there, because it's there in a different branch, and these two branches are not referring to the same. The main branch doesn't know about the existence of a different branch, and whatever contents are there, main doesn't know, so it's not pointing to that branch anymore. Once we merge them, then the main branch will know ki, okay, there are some other files in a different branch there, right? So if I go to my repository again and refresh this, then you will see then it's that there are no commits. There is only one readme file, and there are three commits that was done 2 days ago. So the main branch doesn't know about the existence of a different branch. Okay, so what I'm gonna do is that I'll switch to my branch again, git switch web. Okay, and now I'm going to merge this to the main branch, right? To get merge main, already up to date, because we do not merge it like this way. Okay, I'll go to main and then I'll merge web. Yeah, so now the things have been updated, index is added, one file has been changed, right? Now what if I check here, then there are two files there. To confirm, refresh this, it's still not there. Why? Because it's there in the local repository. We have to push the changes to the GitHub repository by passing the command git push origin main. Okay, we have not done that. So to push the changes, we'll pass the command git push origin main. It's there in the local, but to show it in the repository, the local on the server, that is your GitHub repository on the server, you need to pass the command git push origin main, the name, the branch name. Here I refresh, and you'll see now index.html page is existing here 3 minutes ago, and there are 4 commits. If you go to the commit history, you will see that adding index.html, and this was committed, and this is the commit history. You can also check the commit history in git log. So once the branches are merged, what we'll do now, we'll again check in which branch I am, git branch, and I'm on the main branch now. Now my work is done. I do not need the web branch anymore. So I'll delete the branch git branch d web, and the branch was deleted. Now the only branch remaining is main. And if I again go and refresh, then nothing is changed here, because now the index.html file is there in the main branch, and the main knows about the existence of a new file here. And the initial branch that was created, I deleted it because I just needed to add one file here. This is just for demonstration purposes. You may have many files, you may have a big project, so it depends on the project size, depends on the number of files that you have. But here there was only one file that I needed to add. So now the work is done, and now the branches were created, they were switched, and we merged them. And also, when the work was done, we deleted the branch using the command git branch delete the name of the branch. Okay, so this is how you can create a branch. You can delete, you can switch between branches, and also merge them when the work is done. Okay, so this was all for this video. If you found this useful, please like the video and do not forget to share it with your friends. Do follow the channel, that is, subscribe to the channel, and keep learning, keep growing. Thank you very much.